Okay, the next section is how to measure forecast accuracy. And we do this using the past data. So you look at what the forecasts have been in the past and look at what the actual values in the past. So for a given time period, so if you have the actual value and if you have the forecast, the actual value minus the forecast, so y sub t minus f sub t, so that will give you the error in forecast. So how much the forecast was off by, okay, either on the negative side or on the positive side for that time period. Okay. Now if you take that error and sum all the errors from the past and divide by the number of errors, so that will give you the mean error. So that's one measure of forecast accuracy. Yeah, but here one problem is this error can be positive or negative. So when you add all the errors, some of the positives will cancel out some of the negatives, and even if there are large errors, your mean error could be a really small number. So just because the mean error is really small number does not mean that the forecast has been really very accurate. So the mean error is small, so forecast is extremely accurate. No, that need not be the case. But what mean error actually says to you is that there are sufficient number of positive and negative errors as you go along. So there is no particular bias towards one side or the other. So the forecast is, if the forecast consistently overestimates or consistently underestimates your actual demand, then your mean error is likely to keep going up away from zero, either on the positive side or the negative side. So the mean error tells us not whether the forecast is accurate or not, but whether there is a bias in forecasting or not. So if it is close to zero, there is no bias. If it is not close to zero, then there is bias, which is the same here for mean percentage error, except that in this case, we take the error and divide by the actual value or that time period. So it takes the error and converts that into a proportion of the actual value. So that, and then you multiply by 100. So what you get is here is a mean of the proportion of error or percentage error. And once again, this is similar to mean error in the sense that it does not tell us what the actual error is. It only tells us whether there is bias or not. So let's compute these two next. So here is the example. Suppose we have set of periods and we have the actuals, and let's assume that we have the forecast already given. And this first example, the forecast is supposed to be the value from the same month in the previous year. Whatever the previous year actual value is for that particular month, that is used as the forecast this year. Okay, so this is kind of a naive forecast. We'll talk about that later. So now if you take the actual value minus the forecast, actual minus the forecast, and what you get is the actual error. And this actual error, as we see, can be positive or negative. Okay. So now if you take that error and make an absolute value of that, so make ABS of that, that will be the absolute value, and we'll come to that in just a second. But more important than that, for right now, what we want is you take the error and divide by the actual value. So that is the actual error converted into a proportion. Okay, so let's copy that. Okay, and let's put the border back. So now if you take the average of the errors, what you get is the mean error. And remember, this measures whether there is bias or not. Okay, so here it looks like there is a negative bias. So let's look at the average of the percent errors. Okay, so the average of the percent errors, then what you get is the mean percent error. Okay, mean percent error, like ME, Okay, we'll make that into a percentage. It measures the bias. Okay. Now if you take the average of the absolute errors, and what we get is the mean absolute error. This is also known as MAD. Okay, MAD means the same thing. Okay, so that's our mean absolute error. Now if we don't want the positives and the negatives cancelling each other, like in the ME and MPE, there are two things we can do. One is to take the absolute value of the difference, or we can square the difference. So if you take the absolute value and then average those, divide by the number of errors, you get mean absolute error. This is also known as MAD, mean absolute deviation. Well, if you square that and take the average, okay, sometimes you can do M minus 1 or M. Sometimes the people use just M, which is theoretically not accurate. So that is MSE. Okay. Now if you take the absolute error and divide by the actual error like we did here, then you get the absolute percentage error, and you can do a mean of that. Or if you take a square root of mean square error, what we get is called RMSE, or root mean square error. And it is the root mean square error that is used for developing prediction intervals. So let's do these four next in Excel. Okay, we've already done MAE. Okay, now if you take the absolute error, you divide by the actual error, and we get the absolute error as a percentage, or we take the actual error and square it like that. Okay. Now let's put the border back. So MAPE, mean absolute percentage error, is the average of that. Okay. And we can make that into a percentage. Okay. Now MSE is the average of the squared errors. Okay. So that's MSE. And root mean square error is the square root of that. Okay. Now, sometimes you may want to divide by n minus 1 and not simple average. Okay, if that's what you want to do, and you want to take the sum, and you can then divide this by 11. So then mean actual is average actual, and mean forecast is the average of the forecast.